My name is John Darko. I am a biology teacher at Seneca East High School. I also teach anatomy and physiology, AP biology, and environmental science. But for this project, I chose my sophomore biology classes, and the driving question was, does evolution by means of natural selection happen in humans? And what students did is they did background research on a particular topic, like lactose persistence, evolution of sickle cell anemia, evolution of HIV resistance, and so forth. Particular cases of natural selection that looks like it's happening to humans or has happened in humans, and looking at the data for that and looking at how it has changed certain population of humans over time. From there, they then emailed experts, contacted those experts, and asked them if they would Skype with them. Some of the experts responded back, and that students found was really interesting because they could ask these experts questions that normally they weren't asking me in class, and the evolutionary biologists were able to give them really good information about evolution. After that, my students designed computer models, and that was really the crux of the project. Can they design a computer model that that models how natural selection happens in humans? Computer models work really well because it becomes evolution as a scientific process, as a process that we can run experiments on. And while these experiments are with computers, they're still experiments nonetheless, so they get to see how variables change one population or another population over time. And they're designing it themselves, so it becomes much more tangible in their mind. So take a look at what my students did, and I hope you find this interesting. I gave you a selection of topics for genetics. What topic did you choose, and why did you like that topic, or what did you find difficult about that topic?
We chose erythropoietin as our topic, and I thought it was really interesting just because I didn't know that actually pertained to anything for natural selection until
After you chose your topic, you had to do an annotated bibliography where you had to find resources, cite it according to my specifications, and then write about it.
I felt like there was a lot to do. There's a lot of them. I kept finding repetitive information on some of them. It was good though. I learned a lot from doing those annotated bibliographies, but I think maybe less, maybe next time.
I had you go through your annotated bibliography and find scientists, specifically from your Scientific American articles, scientists there, and then try to construct an email to them saying, hey, will you do a video conference with us in our classroom? Will you do a Skype with us? Now, you two both found people, right, that contacted back. Coda, you actually contacted Dr. Sarah Volkman, right?
Yeah. I went through my annotated bibliography list, and I read through Sarah Volkman's article, and I thought that one was the most interesting to me. So. And she replied back, and she said she would be interested in doing a video conference with our class, and I thought it was fun.
Yeah. They actually sent us mugs and pens and asked us to go to their international conference next October, which is really exciting. You guys got two evolutionary biologists that are really world famous. John Hawks works at University of Wisconsin-Madison, and Nina Jablonski, who is at Penn State University. What was interesting about their video conferences?
About John Hawk's video conference, he actually showed us specimens of hominids that we had evolved from. I found that very interesting.
Yeah, do you guys remember where was that he was at? Yeah, the South African Museum of Natural History, and he got out the tomb child fossil that we actually have a model of, but he had the actual fossil he showed us. Anything else about John Hawks? Okay, and how about Nina Jablonski? Did you guys like the video conference with Nina Jablonski?
Yeah, I really liked her. She acted well. She knows a lot what she's talking about, and we've talked about skin color, and I found it very interesting how she spoke on like how it doesn't mean, or it means where your ancestors were from, not exactly where you're from, but where in the world your ancestors were from, and she talked a lot about that, and I really enjoyed her.
So it seems to model the properties of it correctly, but I don't know if we need to add anything else to
Okay,
model.
so let's, so you're doing Fauvism, right?
Yeah.
So let's run the model and see what happens. Okay, so what increases?
The Fauvism.
Okay, so the amount of people with this G6PD variation. And why did they increase?
Because we varied this variable to 1.3.
What is that variable?
It's it was originally the selective advantage, which we thought should be like the malaria rate. If malaria is more prevalent, then people with Fauvism would be
With that G6PD?
would be more prevalent.
Okay,
because
great. So that seems to be what happens in nature. So let's adjust the malaria to 0 and see what happens. So in an area where there's no malaria, like the United States, what happens?
The Fauvism just drops out immediately, almost immediately.
Okay, so people with that G6PD, what would happen to them?
They wouldn't pass on that trait. They wouldn't reproduce because they have the negative of the Fauvism, but don't have the positive that they can are better adapted to. Yeah.
Each of my students created, groups of students created computer models. Here are some of the models they made, and the students presented those models to the class. They made peer reviews of those models, and then they presented them to biologists from Heidelberg University, and the biologist asked them questions about their model, and my students were extremely good at answering the questions that these biologists fielded. I'm going to show you one model so you get an idea of what my students actually did. So I created a basic template linking these different pages together, and they added all the information, including designing the computer model. The first page is the home page, just some basic information about the model, and they got a lot of this information from their annotated bibliography. The second page is background information, and here she got some information from Jablonski, Nina Jablonski, who we actually did a Skype with, which is exciting. On the third page is background information about their actual model, and here's a link to the computer model that they made. I made a basic sketch of the model, or template, and then they edited those relationships between those. So they, for example, called this light skin and dark skin, and then they had to come up with the quantities to try to figure out how their computer model, their quantitative model, would mimic what they were seeing in their research about the evolution of human skin color. So they saw a big relationship was the latitude, which the latitude then affected the light skin color relationship, which then affected the deaths. And it looks like they probably have it, the higher the latitude, the less deaths is my guess. But we'll kind of unpack it and see if their model works. So after they designed the model, then they came up with this simulation page. And here, what I really like about quantitative models is this trial and error that they did over and over and over again. So let's run their model and see what happens. Their model is graphing three things: the amount of dark-skinned people in a population, light skin, and the amount of resources. There's not a big difference between the light skin, which is at 510, and the dark skin, which is at 490, at a latitude of 45. But now let's adjust the latitude to an extreme all the way at the North Pole and see what happens. When the model runs, your light-skinned people increase, your dark-skinned people end up decreasing. And what's great is the students had to figure out the mathematics behind this to make this model work. If we adjust the latitude all the way to the equator at 0 and run their simulation, we see the amount of dark-skinned people increase and light-skinned people now decrease. And this is the basis of what my students did with their other simulations, varying the quantities and then just experimenting over and over and over again, running models, varying quantities, running models, varying quantities over and over and over again, and they did a great job.
You presented to Heidelberg professors your models. First you presented to the class, and then you kind of made some revisions based off of class inputs, and then you actually presented to Dr. Baker and Dr. Pranesky from Heidelberg University, who are biologists there. Could you speak a little bit about how that was different than taking a test, and whether you thought it was easier or more challenging, or?
Well, it's different from it. I really think the project was, when you're presenting, it was more about people's skills than really knowing your model. And that seems like you didn't do much science, but you still needed to know what you were talking about. But it was more about if you could present effectively and keep people interested, talk about what you knew and explain it in a way people can understand. That's a bit different than the test, where all you have to show is that you know what you're talking about. But when you're up there, you have to really explain it to them, make people understand exactly how you know what you know, and that you know what you're talking about.
Good. Did you find any difference between presenting to the class versus presenting to the experts, or did you prepare any differently?
It felt a little bit different presenting to the professors just because they were college professors, not just like the peers that you've been with for however many years. They were actually, though they weren't that bad to speak to, they were really understanding, and they understood that we were just high school students, not just college students knowing all about what we did.
Okay, so that was my project. My driving question was, does evolution by means of natural selection happen in humans? And this was very useful for students to see how natural selection through variations and selection leads to differences in the human population. And I think my students now have a much better grasp of how natural selection and evolution takes place. And the experts really helped to provide feedback to the students, and got to see that it wasn't just Mr. Darko teaching them about evolution, but some experts were able to answer some of their more difficult questions. So I would encourage you to use computer modeling and get experts into your classroom.